Hi, this is the setup that we're going to use to demonstrate the Model 5950 synchronization between two boards using the Model 5903 synchronizer board. I've got a signal generator generating a 420 megahertz continuous sine wave output through a power splitter, and that is the output of the power splitter is driving channel 1 of each of the 5950s. That'll be used for the ADC synchronization demonstration. And then, of course, channel 1 of the outputs of each 5950 goes to this oscilloscope, and that'll be used to demonstrate the DAC synchronization. If we go around the back to the back of the chassis, you can see how we've got things interconnected. The rear transition module for this 5950 actually has a USB connection to the 5903 on the front. We'll show that to you. And then, of course, we've got two Ethernet cables, one for each 5950. That is going to our office network. And here are the two synchronization cables going into the Zynq inputs of the rear transition modules. Let's follow that around to the front. And you can see the two synchronization cables going into two ports of the front panel of the 5903. And that is the setup. Now, what we're going to do is we're going to log into this system from a remote office using Secure Shell, and you'll see a video depicting the actual configuration and operation of the system. I am going to demonstrate how to synchronize two Model 5950 RFSoC boards using the Pentec Model 5903 synchronizer board. I am using Navigator BSP revision 1.11. And you can see as I look into the directory containing the example MB acquire, which stands for multi-board acquire, there is a README file which is very important to read. The README file describes how to set the system up by interconnecting the USB and Zynq cables properly. It also describes a very important item, the communications server. This is a program that is compiled and run on a host computer that is on the network with the 5950s, and its purpose is to command the 5950s in the proper sequence during their clock initialization so that they can be ready for synchronization. The communication server relies on a configuration file that specifies the executable program, the initialization file, and the IP addresses of the boards. The designation of a 5950 as master simply means which board is controlling the 5903 via USB. Ultimately, both boards receive their clock and sync signals from the 5903. You can see the board initialization files contain the IP address of the board and the COM server. It also specifies a unique output file name and location. In the ADC sync example, the loop parameter is set to 1. This causes each board to execute a single acquisition. After completion, the boards notify the COM server they are finished, and the COM server exits. Let's give this a try. After launching the COM server, there is some passage of time while each board completes its initialization sequence. As I mentioned before, when complete, the COM server exits. And there it goes. Let's take a look at the results. Each board writes its file to a file server on the network. I have written an octave script to read these files and plot them to show synchronization. The script also calculates the phase and ultimately time difference. You can see the nice alignment between the two waveforms, and the script shows about 27 picoseconds of time delay between each channel 1 of each board. Given the 4 gigahertz sample rate, it is clear that this time delay is much less than the 250 picosecond sample period. Now let's demonstrate the DAC synchronization. The COM server configuration file points to the executable file mb-dacquire. This example program has been compiled to demonstrate a triggered chirp waveform. This will make it easy for us to see the synchronization in both phase and trigger point of the two boards. Also, an examination of the two 5950 boards initialization file shows a loop value of 0, meaning the execution will continue indefinitely until the COM server tells the boards to abort the program. Takes a little time to initialize the cards. And the COM server will stay here until the user presses A to abort, in which case the COM server will then notify the two 5950s to exit their program. Here is a video of the oscilloscope connected to the 5950s. You can see the great alignment at the beginning of each waveform.